Okay, so we've just finished getting our FSR sensor to work, which is a sensor the more you press, the less resistance it has. Okay, so now we're going to work with capacitive sensors. These are really unique because what it does is that it kind of just detects anything that's conductive. Like, let's say, it can detect, let's say, skin. Like, it detects how close you are from its surface, you pressing it, and how hard you're pressing it, because there's a dense amount of conductiveness, and you can make it out of literally tin foil or anything metal like a paper clip. So that's really exciting. So we're going to test it out with this tin foil, and we're also going to test it out with the sensor that we created to see which one is more sensitive, which one works more reliably. And the way that it works is actually quite similar to the sensor that we made. So let's pull it out so that we kind of see how a capacitive sensor actually works. How it works is like literally just like this, where you have a conductive surface sandwich, so two conductive surfaces sandwiching a layer that isn't conductive. You can create theremins with it. You can detect people's bodies, movement. There's a lot that you can do with capacitive sensors. And what we can do with Arduino and with this special library called capacitive sensor library is that you can turn any digital pin that doesn't have a tilde next to it, or that does, into a capacitive sensor. It can receive that information. And we can get into how that works a little bit later. But right now, let's just wire it up and see what it does. So what you're going to need is one mega ohm resistor, so your brown, black, green, gold. You're gonna need two, so we're gonna work with, because we're gonna try to work with two of them. So let's get the second one. Gotta find it, so hold on one moment. We've got two separate mega ohm resistors, and let's wire it up. So it's gonna be different than the way that we wired up our FSR. So let's go ahead and take all of this out. Except for our LED, because we want to continue to keep that. For this, we're just going to use one side. We're not going to use this other one. Connect it to a green. Keep colors are the same. Let's bring them over here. Connect it to number 4. Take our resistor and create a little bridge. And then we're gonna have one side of our resistor. Let's connect it in there pretty good. Sometimes it's kind of hard to maneuver through all these silly wires. Okay, so one side is going to be connected to pin 2, and the other side of the resistor is going to be connected to pin 4. So let's do that. Okay, we've got one. So let's get the other one connected. It's going to be that one. Okay, that's correct. So we're going to connect this one to pin 4. See if this makes sense. And connect this side here to pin 6. So essentially we've got And then we want to connect this to here and see how we do. Okay, so we've got those both connected. Let's connect one more LED. Ground, and then connect this long. I'll just make you really long and connect you to pin 10. So we got 2 LEDs. Okay, 9 and 10 are our LEDs. 2 and 4 are one capacitive sensor, which is this one, and then 4 and 6 are this capacitive sensor. And what we're going to do is we're going to try to use a similar FSR. We're going to try to turn on these 2 LEDs. So we've got ourselves wired up, and so let's move on over to Arduino IDE and get started with our code. Okay, so once we open up our Arduino IDE, what I want to do is let's all go to Arduino, to Tools, Manage Libraries. Okay, here we go. And you're going to get a library manager, and I want you to look for capacitive sensor. And you can just type it into the search. Okay, here it is, and why don't you go ahead and install. Okay, so once we get that installed, it should appear here in our examples. And it'd say examples from our custom libraries. So we go down here to capacitive sensor. We're going to open up capacitive sensor sketch. Cool. We're going to take this and just like copy paste it right into our information. We're going to need to add a couple extra things, but why not cut and paste? Saves us time. So if you notice at the top that it needs a library, so it's already called up the capacitive sensor library because it's what we need to be able to transition those digital pins into pins that can detect the information that we need. And we don't need this last one here, capacitive sensor. This one we don't need. So we're just going to put 2 lines next to it, 2 dashes, and then it automatically voids it. If you want to add more, you are more than welcome. We're going to keep this auto calibrate for channel 1 as an example. I guess you can use this or you don't have to if you don't want to. It just sort of calibrates it. And we don't need long, total 3, nor do we need total. Okay, so we've got print T, total 1, T, total 2. We don't need this T, and we don't need total 3. Awesome. So we can just upload it now to see whether or not we're able to read any information. And why not? Let's go ahead and verify. And let's make sure everything is connected. Cool, it is. And let's upload. Okay, we see that it is uploaded well. So let's go to serial monitor. I'm not a fan of these numbers, right? It's like actually quite confusing to see what you see numbers changing, but you don't know which one. Okay, so let's go back to our code and let's not print or check performance in milliseconds. We don't really need that. And we don't really want a tab character for debug window spacing. I'm not really into that. But I do want to put cap sense 1. Okay, yes. And print in a new line our total one. This we're going to call cap. We're just going to call it cap 2. Why not just go, let's not give it such a big ass name. Okay. Equal in a new line. Okay. Upload. See if our serial monitor looks any better. Yeah. Okay. You know what? Let's give it a 1 second delay so we can read our information a little bit better. 1 second. Oh, so much better. Okay, cap 2 is equal to 0, cap 1 is equal to 3. Cool. Let's see. What is cap 1 equal to now? 1 is equal to 366, 365, 346, 9, 12, 35, 66, and now I'm pressing it. So I'm gonna tell you that I'm far away from it. As you can see, getting closer, and 1 is equal to 12, 6, 11, I'm getting closer, it's reading it sort of generally the same. Now I'm just barely touching it. It's at 72, between 59 and 70, and now I'm like moderately touching it, 98. Now I'm just the tip of my finger is just barely touching it. It's at like 100, and I'm pressing it more. 646, 718. Now I'm pressing it pretty hard. 722. And see, look, what we have actually is the bottom. So let's actually flip it around and see what happens when we have it flipped around. See what that does. Okay, wow. So it's already, without no one touching it, it's at 3840. My finger's hovering above. It's at 47. Hovering closer, 60. Touching it a little bit. 78. 114. My finger's on it. 362. 516. 630. 664. About 680 or so. Okay, that's interesting. Okay. I wonder which one's better. So this is actually connected to this metal surface here. But if we flip it around and we have this sort of sandwich going on, I'm wondering if it's a little bit better. What is really great about it is that it creates a situation in which, you're not getting numbers so when you flip it over, it starts off reading 38. Well, now it's at 9. I guess that's not so bad. 11, 6, 69, 193, 245. Back at 9. Okay, that's kind of cool. I'm into that. Okay, so it works better with it facing up. But I will say capacitive sensors are really fickle. They're notorious because sometimes you'll get like wild signals coming in because it's just like being given like lots of electricity, and it's trying to detect, anything that has anything that's conductive. So it's like it could sort of be detecting a lot of different things. So it's a bit erratic. So let's see number 2, huh? Let's see it just like out in the wild. Number 2 is really not giving you very much of anything. That's interesting. Oh, number 2 is now at 1, 2, 3, 0. 0, 0, 0. Does it detect its other stuff? 32, 28, 30. Now let's try it sandwiching between two things. Let's see if this sort of helps it a little. really nothing. But you notice number 1 is like really going off the charts. Wow, 1 is like really experiencing a whole lot of stuff. Okay, let's turn 1 inside out like that. 1 is still receiving. Wow, that's so interesting. So the thing about capacitive sensors is they're going to be kind of fickle. I've only ever really used them with velostat, but I really want to try it with tinfoil. Let's try it with something else. Let's try it with a piece of metal. You can use a paper clip and see how that functions. If it's better or worse or the same, we'll just sort of take a look. I've attached a paper clip here to see if I'm receiving even more information. I'm receiving 0, but now I'm receiving, it's a little bit more conductive. Three, really not 32, kind of. Let's just have it exist on its own. See what happens. Okay, it's kind of doing a lot here with this other piece of it touching tin foil. So it's up at 3026 or so. Now it's at 0, but if I touch it again, dang, 1 is really going off the charts here. I wonder why 1 is so wild. It's definitely sensing stuff. Now we just gotta figure out what it's touching. It's like even more touching. Wow, 1 is like extraordinarily touching stuff. Okay. 2 is reading 30, 28, 31, 31 when I'm touching something else that's metal. But the velostat really increased its ability to detect. And I think this is detecting this, and it's detecting this. That's what this is detecting. So I will say, if you're going to use capacitive sensing, which is incredibly sensitive, use the velostat rather than just using a piece of metal or tin foil. It's just like not as accurate unless you want this to detect like other metal things. It won't detect skin very well, but this does. So I will definitely say use that. But you know, if you want like to, you know, dress your entire room in metal and sort of see what connects to what, and that's like going to be your project or something, then feel free to use tinfoil. Just know that it's going to be a little bit erratic, and it won't be that sensitive. It'll be sensitive to other metal things, but not by a lot. Okay, so we at least got this to work, which is great. And we're gonna move on over to coding this to interact with light bulbs. The first thing that we have to do is we have to define where LEDs are. They're constants. They're constant. They don't change. Oops. Dog's being silly. Okay. So we have to define our LEDs, and we need to also store the values that are coming from our capacitive sensors. So let's go ahead and type that in. Pin 2 is connected to 10, I think. Okay, cool. 10, awesome. And okay, then we're gonna, so we're going to use a different variable than just integers. We want to hold a lot of information because capacitive sensors have the capabilities of getting have the ability to get really large sets of information depending on how big our if we use really large resistors, the larger the resistor, the more sensitive the sensor. So right now we're only using 1 mega ohms, but it actually asks for 10. I mean, you can use between 1 and 10. And if you use 10 mega ohm resistors, or if you create a daisy chain of, all of our mega ohm resistors or a bunch of resistors together, you're going to get a really, really sensitive sensor. So in order to store really large sets of information, we're going to use the function long. So long val 1 2, okay, long 2 okay, we're just going to do this because we haven't defined this part yet. Okay, cool. We're going to set our LEDs to outputs in our void setup. Cool. I think that looks good. We got rid of some extra stuff that we didn't really need, like, I think we're good with what we have right here. So let's move on over to loop. And this looks fine. So serial print. What we want to do is we want to create a value. We essentially are kind of doing it with long total 1 and long total 2, but let's just do it with value because, I don't know, that's what we've set it up. That's how we've set it up. So let's just do that. Val 1 is equal to CS dash 4 dash 2 dot capacitive sensor 30. Boop. Great. And then we've got, oops. Okay. So then it'll print all this. That's awesome. Okay. Now we want to get to our if-then statements. We want to turn on our LEDs if our sensor detects a certain amount of information. And if you remember from the last section, we noticed that in the velostat version of our capacitive sensor was way more sensitive, and it sensed, up into 800, 900. So we're just going to stick with 500 as, our threshold, which I think is pretty attainable for that sensor, but we'll test it and see, and we can make adjustments. But let's do our if. If our value 1 is greater or equal to 500, and our position 1, so our first light is positioned at 0, which is off, then we open up our curly brackets. We're going to open up our curly brackets, and we're going to that means then we'll digital write our LED pin 1 to high. And position 1 will equal to 1. As in, that means now that the LED is high, the position of our LED is like binary code, 0 and 1. 0 being off, 1 being on. So our position of our light bulb is on. Then we'll delay for half a second. Sure, why not? Then we'll close our curly bracket. We have closed our if-then statement. Inside our do curly brackets is our then statement, basically. If this happens, this is what we're going to do. So now we have an else. Else, if val 1 is greater or equal to 500, So basically, if we press it again and it reaches 500 and position 1 is equal to, and it's already at the 1 state, which is on, then we're going to open up our curly brackets again. Digital right LED pin 1 low. POS 1 is equal, goodness gracious, is equal to 0. Let's give ourselves some spaces. Okay. And give another delay of half a second. Why not? Okay. Let's close off our curly brackets because we've got to remember when we open it up, we got to close it. Cool. Okay, let's do the second version. 2 is equal to CS 4 2 dot capacitive sensor 30. Oops, this is not 2, this is actually 6. 30 curly brackets. Oh, you know. Okay, cool. Okay, then we're gonna go. My dog is barking. I am so sorry. And then basically we're gonna do the same thing that we did before, except we're just gonna change things. So why not just copy paste, huh? Just do this whole thing like that, and we'll just change the names. Okay, CS46 cap 2, that's fine. We're gonna deal with value 2 and position 2, because we have 2 positions here. LED pin 2. Make sure we got all of this. LED pin 2, PS, okay. Let's say value 2, LED pin 2. This is helpful. Alright. We did it. Let's just turn this on. Where did we go wrong? If my if-then statement Oh, you know what? I totally forgot to put our positions here. How did I forget to do that? Okay, well there we go. We've made our first mistake. This 1. I could have sworn I put it in. I guess I forgot. Okay. All good. Let's turn it on. Everything is kind of basically been okay. So turn it on. Our board is up and running. It's turned on. Make sure our port is not connected quite yet, but it'll get there. Oh, there we go. Cool. Upload it. Wonderful. Let's pull up our serial monitor. So right now it's kind of at 0. Let's see what happens. What did we get? 28, 36. Oh, we were at 559, 600 pretty much. And we've got our green light to turn on. Let's see. What do we need to turn it on? Touched it and it's turned on. Let's try it like this. My dog. I'm so sorry. On. Off. There we go. We've got on and off. Let's try it with this one. This one's a little trickier. Let's look at the serial monitor. Right now it's only at 6. It's at 32. Ah, shoot, it didn't turn on. It's a little trickier. Ah, how dare you? There were moments where how dare you? It should be on. is total. Oh, well, let's see. Oh, you know what it was? We changed our threshold, and this is where we have to be really mindful. Value 2 is at 500. No, it seems to only be going up to, what's our serial monitor say? It's like what? When we're looking at it, it touches like maybe 10. 0, 0, 4, 1, oops, 3, 5, wow, 7. It's a really wild sensor, this one. Okay, let's just say it's a pretty solid. Wow, now it's at 36. I wonder why. That's really weird. This thing is such a wild experience. Okay. Okay, kind of goes from 0 to 9 as its like normal state, and like maybe 20 is like sometimes when it touches stuff, it kind of gets to 20, 32. Okay, let's just do 20. We are fools. To 20. Oops. 20. 20. Okay. Upload. Now let's try it. Let's try actually folding this in like 3 or even 4, 5. Let's see what happens if we touch that. Wow. Oh. Okay, so it sensed something at almost. It's actually at 28 right now. Let's see if we even remove this and just touch this. Wow. This is way more sensitive, just this folded up piece of tinfoil. So I've folded it a bunch of times. So it's just like way more. Sort of more. How dare you? You were so promising and then you weren't. Let's give it a second. Okay, well, we're learning. Let's get some more tinfoil. Why not? Just continue to work out our sensor. See if it's helpful. It's sort of detecting it, but sort of not. So tinfoil is kind of, wow, look, it's just kind of, that's totally wild. It's like detecting my finger way more than tinfoil. So it's sort of using this metal bit as like the on and off. So what you could do, and what folks have done, people have just used like metal sheets, and that tends to be really productive. I would just use, if you were using tinfoil, I would fold it until it's really, really thick, and then I would use a couple mega ohm resistors, because I think the biggest that we have is just 1 mega ohm. So I would just use a couple of them in a row so that it'll just be super, super sensitive. Or use a thick piece of metal and see if that is more conductive. Or not tin, but aluminum tape. That's really helpful. But right now, it seems like our velostat is really, really helpful in creating like sort of like this 2 sandwich mode situation is actually really great, because what this velostat does, it compresses. When you press it, all of the electrons in it all compress to one spot. So it just creates a super concentrated electron space wherever we touch. And that's like way more effective. Okay, so we've got our light bulbs to turn on, and we're gonna move on over to Max, and we're gonna import all of this information, all of this physical coding, into an environment that can play videos and sounds and text pieces. And for those who are working in pairs, we're gonna work on getting you two to connect to each other and to be in touch with each other, which is kind of if I can just sort of segue into who's holding down and how. That's like kind of a lovely segue as we begin to hold space with each other. Great. I'll see you on over on the and I want you all to pull up Max ID. I mean, just Max MSP.